drilling simulator. This is a full-size drilling simulator. The sound is also simulated. Here we can start working with drilling operation. We can do the drilling. We can control different operation. We can do. You can come closer. All these sections are for the students. These are called the student control station or student units. As you can see, we have a lot of gauges. We can control our manifolds or valves. We can control our drilling mud. We can change the rheological properties of mud. Then we can start doing the drilling operation using drawers, crane. We can change the view. We can go through different views. This is the operational unit. We can change between drilling rig, rotary table and top drive system. I will go through next. We can change the rotary speed, draw working speed, and sort of thing. This one is also the BOP stack, as you might know. We have different kind of BOP, pipe ram, shear ram, and blowing ram, different kind of this. This is also the same, but this is when we are going to work with the offshore cases. Because as you might know, in offshore cases, the BOP stack is installed down with the tiny and sea. So when we are going to work in that condition, instead of using this, we can use this one. This is also for the chart recorder. I don't know why it's not working today, but when we are doing the operation, we can start recording all the data, such as ROP, rate of penetration, weight on beat, and these kind of properties can be plotted here, so we can take a look and see, for example, what kind of operation you are doing. Are you doing it right or not? And this is also the remote choke manifold that I discussed there. But the idea is that when we have a kick inside our well, after we close the well, use the BOP, we need to use this choke in order to open the valve gradually and then get rid of the influx inside. Okay? So, just to give a brief introduction, we will start from the drilling. As you might know, for the drilling, the idea is exactly the same as when, for example, you want to drill a hole inside the wall. You might have a bit, then you need to rotate it and then push some forces in order to do the drilling operation. In order to do this operation, we need, as I mentioned, two different parameters that we have control on. When we are drilling, because we have different kind of formations with different properties, for example, rock strength, pore pressure, and this sort of thing. There are three different main factors that we have control on. Mud weight and its rheological properties, weight on beat, and rate of round per minute, or the speed of rotary table. That these two might lead to the rate of penetration, which is known as the speed of our drilling. So, among all these parameters that are changing in the earth, such as pore pressure, rock strength, temperature, and these sort of things, RPM, weight on beat, and also mud are the factors that we can control them in order to optimize our drilling. In order to rotate the pipe, as you might know, we can use two different methods: rotary table or top drive system. Rotary table is the one that you can see here. Let me change the view. This red one is the rotary table. It means that by rotating it, we can rotate all the drill string in order to perform the operation. Or instead of rotary table, we can use top drive system. It means that we can rotate the pipes from top. The benefit of using top drive system is that when we are working with it, instead of making connection or adding a connection of 30 foot, we can use 3 of them. It means that when, for example, we are drilling, after a while, for example, I drilled from here to here, now I want to add another pipe in order to continue my drilling. In order to do this, if I'm using rotary table, I can only add one pipe, which is each pipe is also almost 30 feet. While when we are going to use top drive system, instead of adding one pipe, I can add 3 of them. So it saves a lot of time for us. drives. It means that when we are doing the drilling operation with top drive system, our speed is much higher because we are saving time. Instead of adding one pipe, we are adding 3 pipes. So we don't need to stop the drilling, add connection every 3 other times. The next one is pulley or drawwork. The drawwork, which is this blue one, part of it is for the drawwork. The drawwork is the combination of some ropes, that can be seen there, that blue object over there, as you can see, right? This is the drawwork. It has some ropes. These ropes go to the crown block, then traveling block. These blocks are a combination of some pulleys. It means that if you remember, for example, when we want to, pull this weight, instead of pulling all this weight, we can use pulley and then have some rope. So in this case, we can decrease the amount of force that we need.
When you say rope, you mean drilling line, right?
Drilling line,
okay.
Yeah, that ropes that are drilling line, yeah, they are called drilling line. So if we rotate the
drawworks.
Drilling, yeah, exactly, into the pulley, instead of, for example, need W as the force we need, for example, if I rotate it 6 times, I might need, for example, W over 6 as the weight of the pipe that I should maintain. So it means that instead of, for example, suppose that I'm drilling a well, which is 10,000 feet. Now suppose how much the weight of this drill pipe will be. So instead of maintaining all this pipe, I need all the weight of this pipe. I might use a lot of blocks or pulleys in order to reduce this weight. So drawworks reduce the load that we are going to work with.
Does that make sense to you guys? He's saying he's basically referring to the mechanical advantage that you get. You get a crown block here and a traveling block here. There's several lines going through them. There's only one line going from the drawworks and to the dead line, okay? But there's several of them, and there you have your hook, and all the drill string is suspended on it, right? So the more you have here, the more weight you can support. If we add one more line, you can support more weight. If we remove the lines from here, well, that reduces the weight that we can support. That's
exactly as you mentioned. So instead of maintaining all this load by drawing itself, we increase our lines. So in this case, we reduce the weight that we need to work with.
Because as you're going to go deeper and deeper, your drill string is going to get heavier and heavier.
Exactly. So this is very important for us. Now the next thing is that swivel. As we mentioned, when we are drilling, we need to rotate our pipes. Why? These pipes, as we mentioned, are connected to crown block or traveling block. So we have a section that is rotating, while we have a section that is stationary. So there should be a sort of tool which is called swivel that connect these two together. It means that the connecting part or the rotating part, which is the drill pipe, this is swivel, and this is, for example, traveling block. So this one is stationary, this one is rotating. Swivel is the agent that connects these two together without having any sort of problem. Okay? So the swivel is the first location, first of all, that the mud is added to the pipes, and also is the agent that connects these two different rotation and non-rotation parts together. Let me show you also here. So if you have this is the traveling block. The crown block. Crown block is stationary. Crown block is there. So if I go down, this is the traveling block. As you can see, it has a lot of lines, or the drilling line. Then this would be the hook and the rest of my operation. So let me also